used to the beeps now. All right, example 24, we're doing direct variation in a practical situation. Most of the times when you're doing these direct variation, inverse variation, there will be a practical aspect to it. It's much more logical to give it a go like that. It just makes some sort of sense. So we're going to find, even though we're not talking about it particularly in this question, find the constant of proportionality. So the constant of proportionality, we're going to use the letter K to indicate that that's a constant proportionality, okay? So when we find it, we're going to work it out. It'll be nice and easy. So let's have a look. We have got garden mulch is sold in bulk with the cost proportional to the volume in cubic meters. So what that's saying is our cost is proportional to the volume in that. So we are multiplying it by some constant of proportionality. And what are we calling the constant of proportionality? Okay, so let's call it KV. So you can sort of see what I'm talking about. You've got this number that you're going to multiply the thing by each time to get your final result. What we have to do is we have to work it out. So that is writing it algebraically. That's question A done. Now, how do you work out what K equals? This is very similar to every other algebraic question you have ever done. I have how many variables in there at the moment? 3. To find one of them, how many do I need? Cool. So I've got 3. The only way to find one, to actually solve for that one, is to have the other 2, correct? All right. So if you're being given a question that asks you to find this and work out the constant of proportionality, they're going to give you an example where you have 2 of the values. Okay. You can see there in question B, the shop quotes $270 for 7.5 cubic meters. So all of a sudden, you're going to be able to sub them into your thing and find out what K equals. So when you're doing this, finding the constant of proportionality, you are solving for K. Everyone happy? All right. So our cost is 270 equals K times 7.5. How do I solve for K? Divide by 7.5. Oop. So I'm actually, So we've got K equals 36. I'm going to get rid of the dollar sign at the moment because it doesn't make much logical sense at the moment because K isn't $36. K is 36. That's just what it is. Okay, but what does that actually mean? It means, well, K equals $36 per cubic meter. Because when we divided by 7.5, we actually went down to 1. It's the unit. So we divided by 7.5. So K equals $36 per meter. Everyone happy with that? Cool. How do we graph that? I'll give you a hint. Constant proportionality means constant gradient. It's just a line. So if you got 0, and this is very important when you're doing lines of best fit and stuff like that, if you got 0 cubic meters, how much do you pay? 0. Okay, so you've got 1.00, okay? That's good. That's not always the case. Sometimes you'll have to, even if no people turn up, you have to pay $100 to book the room. So you would be starting up at 100. Make sense? But in this particular case, 0. And what's our other point? What's our other ordered pair that we've got? What would our volume have been? Give you hints in the question. 7.5. And what was the cost at that point? 270. There we go. We've got a point. You got a line. Everyone cool? Now, why do we do these questions? Why do we find that constant of proportionality? Because now, out of our 3 variables, we have one that's no longer a variable. We know what our constant of proportionality is. It's 36. So now our formula is no longer C equals KV. Our formula is now C equals 36V. So when you get a question that says, all right, well, how much does it cost for 12 cubic meters? You can go C equals 36 times 12. Which equals $432. So you've now solved that. Then when you get a question that says, all right, well, how much can you buy for $600? Well, we already know that C equals 36 times V. So now we've got 600 equals 36V. And how do we find out what V is? What's the volume we can get? Divide both sides by 36. So you get 16 2/3 meters cubed. Everyone cool with that?
Do it as a fraction and not a...
Fractions are exact. If you got 16.667, if you got 16.66 repeater, either of those will be fine. Fractions are just exact.